Good day, my name is Premraj and my matrix number is A170498. Today, I'm going to discuss about the applications of CMC. Now let's move on to the abstract part. Material that can be developed for high temperature applications such as aerospace, automotive and aircraft are known as ceramic matrix composites that we call it CMCs. CMCs are basically very rigid and brittle. This causes it to be very hard to produce because of the rigid and brittle property. So this is where additive manufacturing plays an important role, where additive manufacturing will help to produce a mass production and also help to produce complicated shapes of the structure. Now let's move to the introduction part, where CMCs can be formed using a variety of traditional techniques such as gel casting, which is used to reinforce particles such as viscous and chopped fibers, and also compressing molding and fiber viewing to enforce continuous fiber. For complicated structures and customized CMC parts, the current available methods and preparation procedures are not up to the challenge because of the hardness and high brittle property of the CMC. This is where additive manufacturing will play an important role. Additive manufacturing technology is also known as a 3D printing technology. It's defined by the ASTM, where the process where a three-dimensional model can be stacked by deposition of binders and powders layer by layer from a solid part. Now let's discuss about the applications of CMC for the braking system, where high performance elevator braking systems are commercial applications for CMC friction material. These lifts driving units are designed to operate high-rise buildings with cabin speed up to 10 meters per second. The elevator is brought to a control stop if the speed reaches this value, which is 10 meters per second. So by time when the lift is stopped, the temperature can be increased up to 1200 degrees Celsius, and where CMCs are very suitable for this application because it can control the temperature. It can withstand the temperature. Where next the application is for racing car, where it's the same applications of braking system using the high-rise lift. So next applications is the aircraft, where CMCs helps to reduce the weight, double the ratio, with an improvement of 100 to 200 degrees Celsius in high temperature resistance. CMCs are also able to resist exceptional high temperature, where the jet engines can operate at a great temperature, of course, and also reduce the emissions of carbon dioxide and nitrogen oxide. And also CMCs helps in the fuel consumption up to 8%, and also making the engine more quieter. Next is the aerospace rocket engines, where the temperature of outlet of the rocket engines can reach up to 1700 degrees Celsius per mm square. So it's very obvious that the CMCs are very appropriated and can be manufactured to fulfill the requirement for the rocket engine parts, where it can withstand high temperature. These are the example figures that shows the importance of the applications of CMCs in industry. Now these are the processing techniques of the additive manufacturing process of producing CMC. There are four. First is direct ink writing, second is stereolithography, and the third one is 3D printing, and also laminated object manufacturing. Future challenges and conclusion. In order to meet the increasing demand for CMC parts, especially in the aircraft and automotive industry, the mass production and unable to produce different type of CMC parts must be available in order to fulfill their requirement. So for that, we will focus to the fiber interface layer preparation, where this interface layer is critical to the toughness of CMC, where in EM technology, research is currently focused on the development of an interface layer because it will give an extremely strong bonding in between the matrix and fiber. So next is enhancing the density and precision of CMC component. So in the future study, they should focus on how to swiftly produce large intensity CMC pieces using additive manufacturing technology and reduce the cycle time and also lower the price. This will improve the additional process of optimization and also post-processing technique. Next is developing new additive manufacturing approaches for CMCs, where the powder, whisker and short fiber toughened CMC parts are the primary focus of current additive manufacturing studies. So we'll hope in the future there will be developing more new approaches for the CMCs. So that's all for today. Thank you.